Look around you. What do you see? Maybe a chair, a book, or your own hand. Everything you see, touch, and even breathe is made of matter. It's the stuff that makes up everything in the universe that we can observe. Yes, even you. Matter is everything that has mass and takes up space. It's the foundation of stars, planets, oceans, and even the air we breathe. Understanding matter is like having a key to unlock the secrets of the universe itself. It's a fascinating journey into the very essence of existence. So, buckle up as we explore the amazing world of matter, from its tiniest particles to its grandest structures. Let's begin, shall we? Imagine the smallest thing you can possibly think of. Now imagine something even smaller. You're getting close to the realm of atoms, the incredibly tiny building blocks of matter. Atoms are so small that millions of them could fit across the width of a human hair. Atoms are made up of even smaller particles called protons, neutrons, and electrons. Protons and neutrons huddle together in the atom's center, forming the nucleus. Whizzing around the nucleus are the electrons, like tiny planets orbiting a sun. These atoms, in their countless combinations, create the incredible diversity of matter we see in the universe. From the oxygen we breathe to the iron in our blood, it all comes down to these tiny particles. Amazing, isn't it? We all know about solids, liquids, and gases. Ice melts into water, water boils into steam. These are the states of matter we experience every day. But did you know there are more exotic states out there? Let's start with the familiar. In a solid, atoms are tightly packed, like a well-organized marching band. They vibrate in place, but they don't move around much. That's why solids hold their shape. Liquids are more like a crowd of people at a concert. The atoms can move around and flow, taking the shape of their container. They're still close together though, constantly bumping and jostling each other. Now imagine those concertgoers suddenly gaining superpowers and flying around with incredible energy. That's what happens in a gas. The atoms are much farther apart and move very quickly in all directions. They'll fill any container you put them in, no matter how big or small. We experience gases every day too. Think of the air we breathe, a mixture of nitrogen, oxygen, and other gases. Or the helium that makes balloons float. Those are gas atoms in action. But matter gets even weirder, much weirder. Let's explore those other states, shall we? Section 5, Plasma, the Electric Symphony. If you heat a gas to incredibly high temperatures, something amazing happens. The atoms themselves start to break apart, and the electrons go on a wild, free-flowing journey. This creates a chaotic sea of charged particles called plasma. Plasma might sound exotic, but it's actually the most common state of matter in the universe. Stars, like our very own sun, are giant balls of superheated plasma. Lightning bolts crackling through the sky, that's plasma too. Section 6, a really cool state of matter. Now let's go to the other extreme of the temperature scale, unimaginably cold temperatures, colder than the emptiest reaches of space. This is where we find the mind-boggling Bose-Einstein condensate, or BC. In a BC, atoms get so cold that they lose their individual identities and start acting like one giant superatom. They clump together and move in perfect unison, like a perfectly synchronized dance troupe. Scientists can create BCs in laboratories, but they only exist for fractions of a second. Still, it's an amazing example of how matter can behave in truly bizarre ways under extreme conditions. Section 7. Empty space, you say? Here's a mind-bending thought. The atoms that make up matter are mostly empty space. If you could magnify an atom to the size of a football stadium, the nucleus would be like a tiny marble in the center, and the electrons would be like buzzing flies zipping around the outer stands. So if atoms are mostly empty space, why does matter feel solid? It's because of the forces at play within and between atoms. These forces are so strong that they prevent us from passing right through objects, even though they're mostly empty space. It's like trying to push two powerful magnets together. They repel each other, even though they're not technically touching. Section 8. The dark secret of the universe. Now let's talk about a real head-scratcher: dark matter. We can't see it, touch it, or even detect it directly with our instruments. Yet, we know it's out there, lurking in the shadows of the universe. How do we know it exists if we can't see it? Astronomers have observed that galaxies are spinning much faster than they should be based on the amount of visible matter they contain. There's simply not enough gravity to hold them together. Something unseen must be providing the extra gravitational pull. That something is dark matter. It doesn't interact with light or other forms of electromagnetic radiation, which is why it's invisible to us. But its gravitational influence is undeniable. Section 9. Matter, shaping our universe and beyond. From the tiniest atom to the largest galaxy, matter is the building block of everything we see and know. It's the stuff of stars, planets, and even life itself. And yet, the more we learn about matter, the more mysterious it becomes. The discovery of dark matter has thrown a wrench into our understanding of the universe. It suggests that there's a whole other side to reality, a hidden universe that we're only just beginning to glimpse. So here's a question to ponder. What is dark matter and what role does it play in the grand cosmic scheme of things? The answer, my friends, is out there, waiting to be discovered. If you enjoyed this journey through the cosmos, don't forget to subscribe, like, and share this video. Your support helps us explore more of the universe together.